or not?
Sorry we're going late.
Yeah,
Some
we got
technical
time.
issues today.
20 minutes still. So next up, Jason Williams, Federal Highways Administration for the pool project in Waikiki.
Yes, I'm a contractor that works at Turner Fairbank Highway Research Center up here in Clayton, Virginia, next to the CIA. And so what I do is I run the driving simulator we have there. And so we had a project of a requirement to try to add more GIS information into our scenario. So a lot of these tools are coming out, how to do that. So this is showing the first one we've really done beyond using like just regular USGS type data, or regular earth ground data. So buildings, trees, that kind of thing. This is just showing that Brian Phillips is the head of the Human Factors Group, which is the simulators underneath that. And this is one of the slides I updated. So I'm going to talk about the driving simulator just briefly for any of those that have not seen it. It was in the tour, so you could have seen it. I was hoping that a lot of people would have, but then I'm going to talk about GIS. Now most people know about it, so I'll probably skip over that real quickly. The scenario elements we use in driving simulation, how we can get some of those from GIS environment, the type of tools that seem to be available and becoming easier and easier to use. And then I'll show you, I was hoping to show you a quick demonstration, but that's probably been acting up. So Google Earth seems to work good, so I'll probably show you the Google Earth part. So our driving simulator, we recently upgraded the card cab to 2013 Ford Fusion and replaced the instrument cluster with like a glass cockpit. So whenever we can design then to the experiments and studies that we need for the human factors group, or like if you have the V2V type vehicle communication, we need a new display that we're trying to test in human factors. If the drivers understand, we can just put that in there and then you can see that here. So yes, it's on motion base. This is a little quick slide that shows you the features of highway driving simulator. We actually have very high resolution projectors that are used in some of the like the F-22 Air Force flight simulator. There's not a huge amount of these out here with using these sim projectors from Bob. So we have 3 of those driven, and we have 3 rear view panels that drive for the rear view mirror. But it does give you a full resolution of about 360 coverage with about 300 degrees of the front screens of the projectors. This is showing you the control. It almost looks like a place that you see in a traffic control center. But we have all these displays that show you see one display for each quad of the 4K. So it's 1K per projector. And we have eye tracking equipment, so we know where the participant is looking when they're driving down the road. And we also have other scenario-related controls. So it does actually, with our current projectors, I don't have sound on here, but it does feel kind of like you're driving a highway. Apologize for a little bit of jitter. This was actually done with just a cell phone. I'm standing behind the car to kind of show you how it feels when driving on a highway. So we do visualization a lot, and that's kind of the main focus of behavioral research, but we found with a lot of the work we did in the behavioral research, there's visualization components, especially when we did projects like the divergent diamond interchange, if you're familiar with that. And the visualization became a side product that the MoDOT really was interested in using to try to get the public. If you're not familiar with the divergent diamond interchange, I usually have a diagram for this, but the crossover, so the public was out in arms about this crossover to give you all kinds of accents. But everybody saw our visualization and everybody shut up. So because it didn't look bad at all once you actually had the real 3D view. So that's the power of the visualization and virtual reality both. So GIS. So skipping to GIS, we had the hope of GIS system essentially is any geographically based store of information which you can then cross-index and get data from multiple sources. A big database for GIS, of course, is ArcGIS, and we'll talk about that a little bit more. And so here's so GIS lets us, this is something coming from the Esri website, is the quote. GIS lets us visualize, question, analyze, interpret data, understand relationships, patterns, and trends. It's a lot of big words to say Once you see it, you know what it is. And you can understand how it relates to other stuff a lot easier than numbers, facts, and just other cartoon diagrams. GIS data and applications have become a lot more, who doesn't use Google Maps or almost every day in their lives these days. I remember the time before there was digital maps, everybody had to pull out paper maps and start ripping at the folds. The kids today won't remember that. Think about that. It's going by the way of the VCR tape and 8-track tapes. Kids that are growing up now won't know what the paper maps are. They'll probably not know how to navigate with a paper map either, because it won't, well, push the button, it won't take me right to where I am on the map. Right? Think about that. It's going to be a lost art form with paper maps. So this is kind of just a graphic of showing all the types of layers of data. There's, and you've probably heard this at the conference here a little bit, other than just your hard ground and buildings, trees, and stuff that's on there, your roadways, sidewalk information. Cities, through things like the Smart City program for Federal Highway and the Digital Cities programs, they're putting all kinds of data for service vehicles to be able to find the fastest routes and for places for underground utilities. There's just like a wealth of information that cities and communities are now putting online, including underground information, which is very important, like Kevin was showing, or knowing what kind of soil types of information when you're trying to figure out what to build. This is a resource for GIS stuff for Federal Highway Administration. There is resources for Federal Highway. I think there's DOT resources as well, probably for different areas, but this is one if you're in Federal Highway or doing a contract for Federal Highway, there is a list that can help you find resources. Okay, so what can we, for doing like the driving simulator, get from GIS? Well, the elevation data, the hard earth, is an obvious one. We've really been doing that for like ever, for over 15 years to get information from sections. So many simulators, though, do just generate a local roadway for what they want to try to simulate when they're doing vehicle-to-vehicle type simulation. But we at Federal Highway really depend on having the highway actually as part of normal locations. So I like to call that geospecific locations. We're getting more and more geospecific as opposed to generic, geogeneric. Street data. There's people are aware of open roads. Open roads allows you to add actually data, but there's a wealth of information, and some of the tools now are based on open roads that are coming out. Some of that kind of talk about it. There's vegetation information. It's amazing that we had to previously just model vegetation. I was just looking at pictures to see where they are, but you're now able to get vegetation information, such as Google is sending out fleets of vehicles all the time to collect this data. Well, it's harder to get the data from Google, but you can look at it and see what you have to model for the vegetation density, because they're doing point clouds of where the vegetation is, and putting those objects are really odd looking when you look at it. I'll show you that when I bring up Google Earth a little bit later. So the other thing that the communities are doing, you can see the regions where they have parkland. So there's areas defined as well as the zoning, or if you're building at the larger city level. And so some of that would tell us what kind of models we're going to put in there if we are allowed, if we can have it a little bit more generic, not very specific. The building footprints are very important. And some other, what's called city furniture in the GIS world. If you have the fire hydrants, the street lamps, that information. Many of the cities are actually putting that in there because they need to keep that stuff up to date. Say, hey, that lamp is out on that lamp post, and hopefully somebody has that in their digital database somewhere where it's located. And maybe even they'll have automation that shows, hey, that lamp's out at some point. So the other advantages of GIS is that we're really modeling the real world locations. A lot of the simulations that have been done to date in the human factors realm, like you might have heard a lot of the distraction experiments being done. Many of them, they make up locations. It has a little less ground truth to people, researchers sometimes. If you don't have a real location, and you say, oh, I'm presenting all this data how people drove this, interaction with other cars and stuff. But if you have the actual real Earth, it actually gives a lot more ground truth. We often need to fit the CAD designs to real world location, and as soon as we have a lot more real 3D digital data that matches the Earth correctly, instead of the paper plans we still have to convert often, that will make my job and other people's jobs much easier. The other thing with the GIS is when you model people's houses, I've seen this. They say, oh, there's my house. Oh, and they get more interested in the public involvement section of what you're trying to present to them for the design change that's near their house, and so they can see how it would affect them a little bit better. We can also compare the simulation data, comparison to real world data. There's projects I've heard of that they've been collecting data from the actual crash data traces for some databases. My goal is to actually try to show that in the real world using GIS to build the database around it that's not normally part of the database, but if they have GPS information, we can combine it. And we can create, that's true with accident forensics, if we need to recreate the accident. We're now going to be starting to have all those tools. The more automated it is, the more time we're spending actually looking at the problem of what caused the accident instead of building and recreating the models to do that, because there's a lot of time that needs to be spent. Well, this isn't all for free. There's still a lot of challenges. Integration work is still kind of in its infancy a little bit. Stuff doesn't run at 60 frames per second like we need for real time. It's very important to have minimum, frankly, real time at 60 frames per second. You start to do stereo, you need to double that, because you need to be able to have the computer's capability to generate for each eye, and it depends on the type of equipment and if it's a separate display or not. But most shutter type systems, you're actually having to do it at 120 hertz. Many of the end products are geared for presentation only, some of them right now, and it's very hard for me to get the data off of that, and the proprietary nature of that is also part of the issue still. And we really need to push for more open exports for models if you're building it, and that will make everybody's job easier to interact and share, share the data. So here are some of the modeling tools. I want to ask, how many people have not used Google Earth in this room? Okay, that's very good. There's not a single person. I'm not talking about Google Maps. I'm talking about Google Earth, and it's a little confusing because they got very similar capabilities anymore. ArcGIS. How many people have used ArcGIS? Because that's a little bit more. I'm still preaching to the choir a little bit. City Engine. Use City Engine. Okay. How about InfraWorks 360? It's a little bit newer. But there's some similarities with some of the things you give City Engine, but there's some differences. So since all of you have used Google Earth, you're familiar with the advantages, but there's disadvantages that you can't get this stuff so easy. It used to be that you could get some of the data from it, but then they sold off some of their modeling aspects, Google, to some other company, and then you could no longer share and gain the data, although they're still interested in you putting yours in there, by the way. They still want you to do that. That's because then they can collect your data as well. For ArcGIS, it probably requires a lot of expertise to use. I have a 3D modeler, and he's not quite as technical, but he's really good at doing 3D modeling and artist type work. And we want him to be enabled with the tools without him to have to be a programmer, right? You want your modeler not to have to be a programmer. ArcGIS is a little bit harder to use, but it's getting better. Over the time, I think it's getting better. Every City Engine, for those not familiar with it, it has a lot of promise. It can do anything, frankly. If you have GIS data, you can pull it in. You can use parametric programming to try to generate models directly out of it. You can stand up buildings, trees. That's what they say Esri City Engine can do. But to make it do all that actually takes a lot of time and effort. If you're building for a single project location, it's one thing, but to try to think of it as generic, I could just go anywhere and quickly pull your data, it doesn't work that well, that quick, I should say. It works well, but it's not that quick to do it. Now I found out of this InfraWorks 360, and I will show that some slides from that a little bit more. That is actually geared toward engineers a little bit more, because it's really geared toward trying to do let's create a quick look plan. But it has the capability of bringing in the data at least pretty good resolution, because you can substitute the open street stuff that isn't always at the resolution it's needed, but you can substitute that with your own data pretty well, and you have still a full model, an integrated model that you can then export to use in other forms. And that's why we've switched from using City Engine to using InfoWorks 360, because I think it has a lot more capability geared toward that engineering modeling type build. Whereas City Engine is still geared toward the way ArcGIS works, which is let's put out this database for everybody to see and collaborate with, which is more the concept. The scripting layers in 360, or I should say InfoWorks, I think they dropped the 360, I heard recently. InfoWorks really allows some of that scripting capability as well, but it's not like the primary way of trying to bring stuff up. And there are really good exports for 3D modeling for using in other tools, like what we need to do for real time. So here's you haven't seen 360, that's good, because some of you, many of you. This is kind of how 360 works. You select your region of interest, so let's say I drew this rectangle, and then I can get this result. So what happens is you're going in Bing at the moment, and Bing is who they're using to say what your area of interest on the Earth is. And of course, if you make a really big one, you're going to get a huge amount of data. It's going to take a long time. So you do want to scope it down to your area of interest. So for us, it was in Hawaii. And so we were wanting to visualize driving down this road along toward Diamond Head and across the Waikiki beach here, where there's all the hotels and all the tourists. And I really wish they would let me do some of this the old way, because that meant I would have to go there, take all the pictures, and try to do all the modeling of the buildings. But I'd have to go there for at least a month, maybe 6 months to get all the data. But they said, let's see if you can do this by not having to visit there and see if the tools are good enough. And I think we found they pretty much are. So here, zooming in a little bit more. These are the buildings without showing the shading and the texturing. And this is some of the end point we want. So you can do some exploration with a lower level of details. Now this is what it looks like with the full textured views. And I'm going to zoom into here. And the path we were actually defining for us, so where we actually have to improve the model buildings. So we've got data. We've got pretty good amount of data. There's a lot of polygons, in some ways more than what you'll be able to render in real time. So we still have to build level of detail switching and stuff that you have to do in real time. So we're going to be driving down from here, and we're wanting to have a view where we're looking and driving toward Diamond Head, and we want to see the beach, because that's what we want to see. Now, the beach doesn't look very good here yet, so we had to do a lot of manual adding to the beach. So I'm going to, here's back looking from. So let me kind of try to close this down a little bit quicker here. So Google Earth, you're all familiar with, but you see the quality of the data seems to be a little bit better, but it's not worldwide. So if you're in a rural place, you have to build it real well. Hawaii is very well populated. It's one of those digital cities right here, Waikiki, Honolulu. But you can see there's a little bit of a different, there's a little bit more buildings. So we have some buildings missing that we got from InfoWorks. So we have to build it up. That's one of the challenges. Now you can see, oops, going back one or two far. So there is these tree canopies I was talking about that you see in Google Earth now. Well, you won't see these in every location, because it's as Google gets the locations right. So you're going to see them in more city and urban areas. But the concept of the scripting is that if you got in your database from your GIS, and you don't have this data from Google Earth, because they actually aren't sharing that tree level, by the way. You just can see it in Google Earth. If the city says we planted this tree along the sidewalk, you can go into the model and select a tree and just put that model in. So you can use the information from the GIS database to automatically build up your model and stand up your model. Everybody's used Street View, right? We use Street View to verify when we're building it that when we're driving it down in our simulator, it looks exactly the same. So this is where most of the work comes, where it's made. We go through here and we say, oh, well, this doesn't look the same, so we have to manually change the model. But we have a much better starting point when we use the GIS application. So that's still where one of the challenges is. The level of detail still isn't quite what you want for looking at street. It looks really great from an airplane level, right? Or even helicopter, or a little bit lower. When you get down quite close to the street level, the modeling that comes out directly is still, you know, all these people, we had to model those manually. The water, well, we actually have a plug into the water. The fact that the buildings look correct from the ground is different than looking at the buildings correct from above the rooftops, right? Actually, pedestrians, cars, and things the rooftop. So So it only matters what it looks like from about, yay high. So I'm going to skip through this procedural stuff a little bit, but this is what our final visualization looks like of Waikiki.
Real water or sim water?
It's simulated water.
Just check.
I don't know where you get real water. That shorts out our simulator. So while this is playing, I can take questions, so we can speed it up a little bit.
So what was the software to create the final product? Was it
We-
GIS based?
Well, when you say the final product, it's our simulator software. We've written it there ourselves, so it's based on a rendering engine. It's an open source rendering engine, which is generally used in the sim world, which is OpenSceneGraph. But we've added a huge amount of software layers above that, so it's Archer. That's what the logo up here in the upper right is for Archer. And we've built that for 15 years. So there's a lot there that's geared toward, it's really geared towards studies. So we have parts of it, unlike geared towards recreating a portion of the Earth, we want a portion of the Earth that we can repeat with different signal types or something like that we change for human factors. So we've geared it toward, in the 3D graphic sense of repeatability on the same intersection. Yes?
So is Archer open source?
No, it's not open source, it's not available. So we don't have the staff to maintain something like that. So there was interest, but there's no funding model to have the government go into trying to host an open source software.
So that software, Archer, basically brings in all the information from different sources.
It's running off the model, but we have a scenario script code in there that says how we use the pieces. So we don't create one monolithic model. We create anything we want to change has to be a separate model, and we switch out that piece. So we use a lot of switch nodes, it's called in the scene graph. And this is geared toward a particular participant might have a different set of switch nodes that are going to be presented for him because of different case that they're going to be shown. Any questions? That's the end of this video.
So the buildings that we see here, are they coming out of the InfraWorks?
These buildings here, we switched to InfraWorks. When we did this, which was actually 2.5 years ago, we actually were using Esri City Engine. However, the challenge here was that Esri City Engine, we had to touch almost every building. If we drove right next to it, we'd have to touch it. If it's within a block away, that's fine. So the advantage of using this type of stuff where it's a little more generic and kind of fits, but it's not exact, when it's blocks away, it's great. Because you don't have to do anything with it.
Yeah, because city engine facades are kind of limited. And
Yeah.
they don't fit well, like a window like right up next to the city.
Right. So this street level, our modeler changed these, but he
Yeah.
could use the footprint pretty much.
Yes.
And in some cases, looking at street view, you notice, oh, it didn't have the right data for the number of floors as well, or the facade was just wrong. So he had to touch a lot. So there is no totally animated process yet.
So that's a lot of work.
It is. Creating this entirely, I mean, one of the hopes was to speeds us up, but we hadn't attempted to just do this many like buildings and stuff in a scenario before. But, so it took us probably a good 3 months to build all this. But I would expect it would have probably taken us closer to a year if we were modeling every single building and everything that we're using without being able to pull GIS data.
I'm wondering if there's a way to kind of match a video, like if you just drive down the street and take a video and match that with just the animation of what's changing.
Well, if Google hasn't already invented that for the Google Earth, then you know it doesn't exist. Maybe they have it and they don't tell people about it, but the movie industry is the one that's really ahead on trying to do image matching. And I think others are using that too. But, so, okay, is that it for questions?
Yeah, so can we wrap it up?
Yes.
All right, well, thank you very much. We're past our time, so we don't have time for a group discussion, but if anyone wants to stay in this room, I don't think we're being kicked out right away. Feel free to talk to the panelists. And this wraps up the entire symposium, so thank you everyone for coming. Thank you. Thank you, Rebecca.
Good job, guys.